All right, so determinants for a 2 by 2, very simple. You multiply your diagonals and subtract. So then you have a 3 by 3 and you end up having more diagonals. And so what they actually do here is they do the same direction. So they'll say this diagonal and then plus this diagonal, but you see you run out of room. So you have to actually take this column and drop them over here, right? Which is what they did. This diagonal, and then we do this diagonal and they grabbed him. And then they do this diagonal and they grab that guy. Yeah, and so then they subtract and they go the other direction. And that's technically what you can do. You can actually shift these columns over so that it creates 3 diagonals. And then you can subtract the other way. All right, that's how we get the determinant here. But there's also a shortcut to this where you can just use 2 by 2s to do this. All right, so I'm going to show you the shortcut. And then you can choose which way you want to do it. The shortcut is just to pick a column and to create 2 by 2s based off of that column. All right. And so the example that they have here is our column or row, actually. So the example that they're using here is they chose this row. Okay. And what you do is you take the first guy in that row, which is this A right here, and you just assume the other pieces of that row and column that he's in don't exist. All right. And you choose the 2 by 2 that's left over, okay? The 2 by 2 that's left over. So we have the A, and he's right here. And then we have the 2 by 2 that was left over from every piece that isn't in a row or column as the A, in the same row or column as the A. And what you do is you just do the 2 by 2 determinant here, multiply and subtract, and you multiply it by that answer by the A. And then you move on to the B. And you see they have the B times the 2 by 2 that's left over when you don't have the row or column of the B. And you do that 2 by 2 determinant, which is very simple, multiply and subtract. And you multiply it by the B. And then you have the C. Same thing, eliminate the row and column he's in. There's going to be a 2 by 2 left over. Do that 2 by 2 determinant and multiply by the C. And you add all your guys together and that's your determinant. So you just have to do like 3 2 by 2s.
You always have to subtract B and add.
So the question is, why did they subtract? Good catch that they subtracted this guy. When you do this, first of all, you can choose any row and any column. So I can choose this row and do those 3 by that row. Or I could, if I want to, I could actually choose this column. All right. The reason I would do that is, let's say the middle column has a 1 and a 0 in it. Well, that's going to make my determinant significantly easier to do, right? Because one of them is going to be multiplied by 0. I don't have to worry about him at all. The other one's going to be multiplied by 1. All right. What happens, however, is you add all of them. All right. So we're going to say the first one plus the second one plus the third one. However, if you choose a row or column, there are certain ones that will flip the sign when you do the multiplication, which is what happened with this B. All right, so you just have to make a note of this. If it is on the diagonal, the signs will stay the same when you add them up. So the A will stay the same. This is only for the guy on the outside, only for the guys on the outside. The inside guys always keep their numbers the same. But the guy that you're multiplying by, the one that you're actually pulling out, all right, if they're on the diagonal, they're going to be exactly whatever they are. If they're not on the diagonal, you're going to flip their sign when you multiply them, which is why this B flipped the sign. You'll notice that nothing's flipped inside here. None of these guys flip signs. They don't. Inside the 2 by 2, you don't flip the sign. It's only the guy on the outside that you're multiplying by. And we're actually going to do one of these so you can see what I'm talking about. No matter which row or column you choose, you will get the same determinant. Every time you'll get the same determinant, okay? So I always choose the easiest one, personally, all right? We're going to do one. So it's hard to visualize this here without actually doing it, all right? So let's look at the first example. So in the book, they're actually going to do these diagonals. They're going to say this diagonal plus that diagonal plus that diagonal. They're going to shift these columns over. Then they're going to subtract and do backwards the diagonals. Okay, so in your book, it's not going to look anything like what we're about to do. All right. So if I were looking at this particular one, which column or row do you think I would choose?
The bottom. bottom.
Yeah, either the bottom row or the first column, one or the other. Okay? Bottom row or first column here. Why do you think I would choose that? Because there's a 0. Anytime there's a 0, I'm going to grab that guy. All right? Because I don't have to worry about him at all. Okay? And so I'll actually show it to you two different ways. So I'm going to show it to you maybe first with this column. All right? These are going to be my outside guys. Okay? So my first outside guy is a -1. So I have a -1. All right? My second outside guy is a 2. Is that on a diagonal? Is that 2 on a diagonal of my matrix? No. So I need to switch that sign. It is currently +2. I need to make that -2. Okay? My third one in this one that I chose is a 0. Okay? Now I'm going to look at my determinants that are inside. When I look at my 1, I'm going to delete everything that is in the row or column of the 1, and I have a 2 by 2 left over. It is -4, 6, 1, -1. Okay? You see that? Everybody see that? All right. Then I'm going to do the same thing with my 2. If I get rid of the row and the column that's in my 2, I'm going to have another 2 by 2 left over. The 3, 5, 1, -1. Everybody see that? So far, so good. And even though it's a 0, I'm still going to show you this last one. All right. And so now let's look at my 0. If I get rid of everything in that row and in that column, I have another one. 3, 5, -4, 6.
So would you negate the
Opposite. All right. You are adding up all of these. So you're going to add up this one and you're going to add up this one. Okay? And then I'm just going to do the 2 by 2 determinants, which are very simple, right? So for this first one, -4 times -1 is 4 minus 1 times 6. And I am multiplying that by -1. Right? Plus, I have a -2. 3 times -1 minus 1 times 5. Right? Plus, and this is why I chose the 0, because it doesn't matter what's in there. It does not. I'm going to multiply him by 0. Four minus 6 is -2. Times -1 is 2. -3 minus 5 is -8. Times -2 is 16. And of course I have this 0. So what is my determinant? 18. You'll notice when they did the 3 diagonals, shifted it over and did subtracting the 3 diagonals, they got 18 as their determinant.
Why is there the -1, 2, 0, 3?
Because you have to shift it over. You have to, like, when you do those diagonals, you have to recreate those columns
Shift over the first 2 columns.
at the end. At the end.
No.
Right, yeah. Yeah. All right. And it does not matter which row or column you do for my way, okay? For the other way, you have to do those 3 and you have to subtract the group of the other 3. Okay, it has to be in that order. All right, so go ahead and try. Top of page 203, there's 3 of them. I can tell you which way I would do for C, personally.
We're doing
All 3 of them.
Oh god. This will take me a while.
Would it just be 0?
Yeah. See how my way makes that really easy to see? I'd still have somebody mess up. Maybe not in here. In years past, I would definitely have someone mess up. Mikey, can she share your book? She doesn't have her book. At least she's not wearing a Washington outfit. It's not going to happen this year.
Yeah, I know. It's not.
Okay. And are all of your coaches and all out of jail now or no? Actually, don't mind Washington as much as I mind the Patriots. So. I'd rather be a Washington fan than a Patriots fan. Eagles aren't going to win their division either, by the way.
Yeah.
I only know this because they're in our division.
I was gonna go like last year. I think that was.
I got a really big number.
Yeah.
You already done?
I actually never forgave the Eagles for rehiring Michael Vick. I still am holding a grudge against them for rehiring him. So he like personally killed dogs. He was a dog fighter and he would like strangle them and drown them if they didn't win for him. Went to jail for a year and then the Eagles picked him back up.
Why would you pick him back up?
He said he was good.
I don't care. He's not good. If you're not good.
He wasn't very good after he came back. Actually, he didn't do very well for very long. He wasn't a good person, although a lot of NFL players aren't good people. So, did you figure it out, Carissa?
I think so, yeah. I was just gonna ask, like, in that second part, you know, when you times the A, B times B.
3 times negative 1.
It's a
Uh-huh.
minus always.
Always a minus. Mm-hmm.
So yeah, for B it's always.
Minus. It's always in the determinant. It's always minus. Oh, you mean the negative 2?
Yeah.
That depends on which column or row you chose. If they are on a diagonal of the original matrix, you don't change their sign. If they are the 4 not on a diagonal, then you change their sign when you add them up. That's kind of this whole class is math. You mean like your multiplication? Determine whether the matrices are multiplicative inverses of each other. Are they multiplicative inverses of each other? This is going to be exactly the same as if you were doing a 2 by 2. If they are multiplicative inverses, then when you multiply them, you should get the identity matrix. And the identity matrix for a 3 by 3, identity matrix always has 1s in your diagonal and everything else is a 0. All right? So if you multiply those two together and you get that answer, then they are inverses of each other. If you do not get that answer, then they are not inverses of each other. That's just the whole point here. They gave us really easy ones, though. It doesn't look like it, but they did. So on this first one, I have 1 times 0. 5 times 1/5, right? Negative 1 times 0. So far, so good, right? I know. 1 times 0 5 times negative 1/5. Negative 1 times negative 1. That's going to be 0. 1. 5 times 0. 1 times negative 1. So my first row looks good. That's going to be 1, 0, 0. And do the same thing across. It actually is going to work out to be, by the way, 1 times 0. 0 times anything. And then negative 1 times... Oh, wait, here we go. Nope. 1 times 0. 0 times that guy. Negative 1 times 0. There we go. And all the way across, you're going to do this. 0, 0, 1. And then 1, 0, plus negative 1. Right? See what I'm doing here? I'm just multiplying. I'm multiplying row by column. I'm doing matrix multiplication. Then I'm going to my third row. So 1 times 0, 0, and 0. 1 times 0.
Oh, you're doing the multiplication.
I'm doing matrix multiplication. Everybody see that?
Yeah.
It's just what we learned.
Right. I'm just doing it quickly. You'll notice that
I was just looking.
this is
for-
1, this is 1, this is 1. Everything else is 0. So yes, they are multiplicative inverses of each other. So that's all they're asking is, are they multiplicative inverses? You know they are, because in any matrix, whether it's 2 by 2, 3 by 3, 4 by 4, you're going to get what's called the identity matrix. This is going to help us when we start solving some matrix things later on, systems of equations with matrices, because this is going to help us solve those. So if you get the identity matrix, it just means that it is diagonal. The diagonal is always 1 and everything else is 0. That's all they're telling you there.
Can it be the other side?
Nope, it has to be this diagonal.